string of a guitar. The string makes a vibration that can be seen. This vibration causes the surrounding air to vibrate. The vibrating air then causes the human eardrum to vibrate, which the brain interprets as sound. This is what we consider to be a sound wave. The vibration we are seeing is not the actual sound wave. However, much like the actual sound wave, this vibration can be represented by a sine function. The equation for a sine wave is y equals a sine b times x minus c plus d. A, b, c, and d combine to determine the shape and location of the graph. A is the amplitude, which in terms of sound waves is the maximum distance reached from the line of zero. The closer the distance to zero, the lower the amplitude, the quieter the sound. The farther the distance from the line of zero, the higher the amplitude, the louder the sound. Therefore, amplitude represents the volume of a sound. B is the period, which is the length along the x-axis of one complete wave of the graph. In terms of sound, period is the time to perform one complete cycle. The number of complete cycles that happen every second is the frequency, which in this case is measured in hertz. The frequency is used to determine the sound's pitch. The higher the frequency, the higher the pitch. The lower the frequency, the lower the pitch. Each individual pitch on a musical instrument corresponds to a unique note. C is the phase shift. Phase shift is the number that shows how far the graph must be moved left or right to match a graph of the same shape. D is the vertical shift, which is how far up or down the graph shifts from the x-axis. In terms of sound, the amplitude A and the period B are most important.
And that is the President's word on the Ebola crisis. And now, my fellow Americans, a message on sound waves. So, when you play the note E2 on a guitar string, you are hearing the vibration of the string passing through the air to your ear. The note E2 vibrates at roughly 82.4 hertz a second, or 82.4 cycles per second. This means one single vibration of the sound wave produced by the note E2 occurs roughly every 12.1 milliseconds. And that, my fellow Americans, is a message on sound waves. To explain the note E2 in graphical terms, the x-axis will equal time, and the y-axis will equal volume and or amplitude. We know that the note E2 cycles 82.4 times a second, or at 82.4 hertz. For our purposes, x will equal 1 second on the sine wave equation, and b will equal 82.4, because that is the amount of time the note E2 cycles in 1 second. So if we solve the sine wave equation, we will find that the period length is 0.0121 seconds, or 12.1 milliseconds.
You got your tablet.
What?